Hello everyone. In this video we will try to cover some problem statements which has the similar solution. Right. So I have categorized some problems into a group which is this is GA and this is GB. Right. So all these three problems have the similar solution and all of these problems have the similar solution. Right. Obviously, like I'm not saying you just copy paste the normal code and all will work. You need to, change the formula, right? Change formula. The small things should be there and change data type according to the problem statement, right? Data type. So these small changes would be there, but anyhow, the crux and the solution would be almost similar, right? For this, we need to use the min heap. For this, we need to use the max heap, and you will find out that okay, the solution which we are writing is almost similar, right? There is nothing new about this. This is what we learn, right? So for the sake of this video, I'm not going to cover every problem, right? Every problem solution in this video only. For right now, what I'll cover is this k closest point to the origin, right, from the group B. But in future, I'll try to cover the rest of the problem statement as well. Or what you can do is, the problems are most almost similar. So if I teach you this one, right, if this one is done, then you will able to try these two problems. And if let's suppose I'll try to teach you this one, then you can try out with these problems, right? So in this way, you will also able to learn and grow yourself more. My main motive is to categorize you guys into a problem statement which you know already, right? Or which you able to decode it by yourself if you know the basic idea of it, right? You know how to approach this problem and how to write it down and solve it and break it apart if the similar problem arises. Okay, so let's move to this problem statement, right? So initially you have been given a list of points inside the vectors. Now the points are given in the way of x comma y on the xy plane, right? And you need to return the k closest point to the origin, right? Now what the problem says is, let's suppose you have a coordinate x comma y. This is x2 comma y2, x3 comma y3, x4 comma y4, and so on. Like there are many other points, right? And this is the origin, obviously, right? 0 comma 0. So what it asking is basically on the core level that you just find the distance between each and every point, right? This one and this one and this one and so on, right? You just calculate this d distance, d1, d2, d3, and so on, and then dn. You just calculate all the distance for each and every point from the origin, right? After that, after calculating the distance, out of these, return the k points which are closest, right, or which are the smallest one. So like d1 and d2 are the distances, right? So till dn. So you just need to find out which all kth are the smallest, right? Top, you can just take all the distance and sort it, right? And out of them take out the first k distance, right? So that you will able to find out that okay, distance 1 to distance k, I got it out of distance n. So you can just find the points coordinate out of them and then you can just simply return it. So this is what problem is stating, and I also probably said one of its solution, that you just find the calculate distance, this Euclidean distance to all the points, and then sort it uh, also in a proper data structure so that you can also get the points as well after removing. And once you do that, you just return the k closest one, right? But that is like the basic brute force approach. Nobody will gonna approve that solution. They will say okay fine, but they want you to use some other data structure which will help us out, right? Okay, so what you can think of. So in one of my previous video I explained that if the problem is asking about toppest, right, or the biggest or the largest, right, or in some like people are asking about closest, minimum, right, minimal, right, or like any like smallest, right, then these terms will help us to identify the problem that the problem is asking you, to solve it using heap, right? So this, the problem is asking you to solve it heap, right? But now, okay, you will say that, okay, let's say we also believe that, but how we will try to solve it using heap. So what we can do is we can try to use a max heap in this problem statement, and then what we will try to do is we will create a container which will be of max heap, right? And we will try to insert the points comma distance. This is p1, or the p1, like, which is the given to us, the points which are given to us. So this is that point which is given to us, and this is the distance of this point from origin, right? So our max heap, what it will do, it will take the on the it will take the top element which has the maximum distance, the d which is greater, right? So it will take that point to the top, right? And what we will gonna do is we will try to remove that distance. Like, we basically don't want the largest one, right? And max heap, what it will do, it will take, it will put the top it will make the top element which has the largest distance from the origin, right? And we simply don't want that, so we can just simply remove it, right? And we can remove it and insert it until I have only k elements left, right? So that's how we can try to approach this problem statement, and we can use max heap for this purpose, right? So let's try to solve this problem, right? And it might be confusing in the initial times, but while we are writing the code, it will be easy to understand more, right? So let's start writing the code, right? Now let's take the size of the vector which is given to us, right? Okay, great. Now what else? Now I need to define a priority queue, but priority queue would not be just as simple as it looks. We just need to define pair, right, which will contain the double, right? This double is basically the Euclidean distance. Double, the structure, I'm saying about the structure, double comma, I would say int, right? So this double would be the distance, and this int would be the index, right? So I have defined it as max heap, right? Okay, so I have defined it the pair of max heap, right? Initially I will store the index, or I mean not index, I mean the Euclidean distance, and then later part it's the index, right? After that, what I'll do, so what we need to do is we just need to start iterating it, right? We need to iterate it till the end, and first we need to find the Euclidean distance. So how we can find the Euclidean distance is, we just simply need to use this formula, okay? So we can say power of plus power of, and then we can just simply say that, right? Now I'll say points of I comma 0 comma 2, right? So if you try to understand, it will just simply take the square of the powers which I'm trying to do it, right? And then I'm saying points of I comma 1 comma 2. Now you will say that, hey Sonu, what is this? Like, it's x1 minus x2. So we need to calculate it from the origin, right? So one coordinate of x is 0 and one coordinate of y is 0, and the square of this will be positive, right? So I'm just simply taking the point and squaring it, and then I'll plus it. I'm gonna just add it and then take the root. So I'm simply just plussing it, squaring it, and then taking the square root of that. So don't confuse that, hey, you didn't use that formula, right? Okay, so I have calculated the Euclidean distance. Now what else, right? Now just simply we need to push it in my max heap, right? Max heap dot push. What I need to do, I need to insert a pair z comma I, right? I is basically the index for that point which we are storing, or which we are calculating the distance. And one improvement which we can do is that this z, right, this not might probably could be the int, it could be double as well, right? Because we are calculating the square root and it should not be in integer, right? So this is, we can update. And after that, like we just don't need to increase the size of our max heap, right? We just need to make it till k. So it will be help us to it will not reach the depth of the tree will not reach by log n. We need to make it by log k, right? So what we can do is we can say that, okay, if the max heap dot size is greater than k, the k which is given to us, then what you can do, we can say max heap dot pop, right? So till here my max heap will be ready with the all k closest element, and then I need to define a vector of vector int, by which I just need to return the answer like that. But the answer is empty, and I need to insert some things. So I just need to write max heap dot size. If it is greater than 0, I'll simply take the elements, right? If max heap dot top and max heap dot pop, right? I just write it in the one line because it's easier for me to track it, right? So this is how it should go. Right now what I did is I just first take the size of the vector which is given to us. After that I have defined a max heap or priority queue with a pair of double and integer. This double is for storing the Euclidean distance, and this int is for taking the uh, for index of the points which are taken to us, right? It will help us to getting the points. uh, I think I should probably use the second one, right? Because this is how it will go. And yeah, if I will just keep inserting it, and if the size of my max heap is greater than k, then I'll simply pop it down, right? So I hope this should work. Now let's try to run this solution, if this will work or not. Compiler error. Okay, point or points. Fine. Now let's try to run it again. And yeah, I hope this will work. So that's how I should suggest you to solve it by yourself. And again, like, just try to solve the other two problems in this part, right? So you understand the understand the problem very well. And I'll also share the solution of this problem, and you will also see that the solution of these two are almost similar. We'll just simply need to add it and then pop it, and then I will have a priority queue which contains all the k elements. K is the factor which I've already explained. So that's how it goes, and this is all what I can say about this video. In the later I will explain this one as well, the kth largest element, and then you guys can try up these two. So that's all for this video. I hope you learned something, and I have added some small value to it. So thank you so much for watching.